So, here's the next chapter. You recording now?
You're live.
So, this next chapter is talking about how the planets move, the motions of the planets. So, what the ancients thought was that the Earth was at the center of the universe, and that all of these stars were spinning around the Earth. So imagine a little Earth, like they show here, in the middle, and all of the stars spinning around the Earth. And they called this thing the celestial sphere. And they thought it was a giant sphere in space that somehow the stars were kind of like painted on by some supreme creator. God painted on stars on a big canvas that spun around the Earth. And that's how they explained the stars going across the sky, the sun going across the sky. That they explained that by there's this big canvas and the sun is on it, and the moon is on it, and the stars are on it. But they noticed that the stars kind of stayed in the same position every night. And they could be predicted, the locations of the stars going around. But the sun and moon and planets all changed position on the celestial sphere. Like one night a planet would be next to these stars, but the next night it'd be next to these stars. And the next night it'd be next to these stars. The planets actually moved along the celestial sphere. So the planets were given higher status. They thought the planets were other gods that might be moving around. Somehow these gods were spots of light that could move around on the sphere. A lot of the planets were named for gods, like Mars is the god of war. Venus is the goddess of love. Y'all know about this, ancient Greek mythology. And they noticed that the planets did a certain movement. The planets, so here's Mars next to these stars, and a day later or a week later, I'm not sure the amount of days between photographs here, but then Mars is there a little bit later, and Mars is there a little bit later, and Mars is there a little bit later. Mars is moving compared to the background stars. And then all the planets do a little curlicue like this and move on. Go forward, and then backwards, and back forward.
Do they go into a little orbit? Or?
They go into a little loop. And no one could understand why that happened. And so scientists tried to explain these loops. And they asked a scientist named Ptolemy to try and explain the loops. Have you heard of Ptolemy before? Ptolemy wanted to try to explain the loops. And the name is slipping me what they called the loops. Does anyone have their book open now?
Yes.
Can you read what was the loop called? It's an epicycle.
Is that it?
Ptolemy called the loops epicycles. And he,
I thought it was retrograde.
retrograde motion, right? Retrograde motion. It's explained by epicycles. So we call this retrograde motion. The planet is going forward, and then it loops and goes back and goes forward again. That's retrograde motion, going backwards. Why does the planet go backwards for a time and then keep going forward? That's weird, the ancients said. And Ptolemy said, no, let me tell you. I don't know, trying to deal with Ptolemy. I've never heard him. But anyway, let me tell you what they're doing. They're going in circles. Now, the ancients thought the circle was a perfect shape. And so they wanted to try to explain everything in circles. So what they said was that here is, Ptolemy said that here's the Earth at the center, and here is Mars, the planet, and that Mars was doing circles as it went around in a big circle around the Earth. And I like to think of this like teacups. Have you ever ridden the teacups at Disney World?
Yes.
Okay, so when you ride the teacups at Disney World, you're in a cup. And you can spin the thing. Y'all know what I'm talking about? And you can spin around in your cup, right? And get yourself real dizzy, and that's fun. But at the same time, the cup is moving around the center because the whole thing is spinning, right? So you're doing little circles in your cup while the whole thing's spinning, right? And then at times, if you were somebody just standing there watching, because the whole thing's spinning, you would be moving this way, but every time your cup did a loop, you'd go backwards, right? You'd go backwards a little bit every time your cup did a loop. So you'd be going like this compared to if somebody was watching you from the middle, right? You'd be doing loops. That's how Ptolemy explained the motion of Mars. He said Mars does little loops. They're called epicycles, he called these little loops, as the whole thing spins around the Earth.
How is there retrograde motion?
Retrograde motion is when you look like you're going backwards compared to the whole loop.
He was right. It was just not the Earth. It was the Sun. Is he right about
He
that?
was not right.
He's not right about the motion?
No. It was a good guess. And because Ptolemy was so smart and famous and had made a lot of great observations, they figured he was right. And for 1,600 years, they thought this was how the planets did. But they don't. He was wrong. I'll show you what's really happening. Oh, and by the way, he drew this picture of the epicycles of all the different planets. And the only planets that could be seen with the naked eye back then were Mercury, Venus, Mars, Jupiter, and Saturn.
How are they supposed to know those are planets compared to the stars? in the sky?
Because they were doing epicycles. And the stars stay fixed. The stars don't do epicycles. Okay? That's how they knew those were planets. They called them planetes, which means wanderer. That's where the word planet comes from. Because it's not fixed on the celestial sphere, it's wandering around it, moving and doing loops. Isn't that cool? So, Ptolemy drew this big picture of the solar system that we know is wrong. But everybody thought it was right because it was Ptolemy, and you listen to what Ptolemy says because he's smarter than you are. But some guys came up that were actually also smart. Like this guy, Nicolaus Copernicus. You ever heard of him? Copernicus figured out exactly what's happening. And he said, no, the planets aren't going around the Earth. Copernicus said the planets are going around the sun, including the Earth. The Earth is going around the sun, and all the planets are going around the sun. And the reason why it looks like the planets are doing loops is because the Earth is passing the planet in its orbit. Now, you've probably all been in a bus or something and looking out the window and another bus or something pulls along. And as you pass that bus, it looks like that bus is going backwards. Have you all familiar with that situation?
Yeah.
That bus isn't going backwards. It's just that you're going faster than that bus. Right? And so if you imagine the Earth here and Mars here, I'll get out a couple of little... Oh, I just did that to you. Need to charge those at home. That could have been bad. So let's say that this is the Earth and this is Mars. Okay? And they're both moving. Now, the sun in the middle, kind of where Chris is sitting, let's say that's where the sun is. And Maggie, do you want to come hold this for me? You be the Earth?
Sure.
Okay? And so imagine now the Earth moves faster than Mars. Okay? So if Mars is kind of moving slowly like this, you walk past it, now it looks like Mars is going backwards from the Earth because she's passing it. You see what I'm saying? So if you're looking at Mars, and all of a sudden it looks like you're going backward. But Mars will keep moving Now what I want you to do is I want you to turn, because again Chris is the sun, and I want you to make a turn and start heading for Ymir. Okay? Start heading for Ymir, and you're turning, and Mars is still going kind of slowly. And now if you're looking at Mars from the Earth, okay, stop right there. Now look up here. Now if you're looking at Mars from the Earth, it doesn't look like it's going backwards anymore. Because Mars is way out here, it looks like it's going this way, because she's turning that way. You see what I'm saying? And if you're actually looking at Mars, it looks like it's going forward again. So it looked like as she was passing it, come back here. So here is now you're turning inward toward turn inward this way. Go that way. There you go. Okay. So let's do the whole thing again. What I want you to do is you make a curve toward Ymir.
Okay.
And I'm just going to slowly walk this way. I'm going to walk slower than you. So Mars is going forward. Now she's passing it. Now Mars looks like it's going backward. Now turn toward Ymir there. And now Mars looks like it's going forward again. You see what I'm saying? That explains it. Copernicus came up with that. And you don't need the epicycles. It's a simpler explanation. But the explanation involved everything going around the sun, not the earth. It was written in the Bible that the earth was at the center of the universe. And this very much upset the Catholic Church. And they wanted Copernicus, they wanted to shut him up. They wanted, a lot of them wanted to kill him. But Copernicus was famous. It'd be like killing somebody you like on TV, I don't know, Drake or somebody. And you're not going to do that because everybody likes them. So they didn't kill him, but they asked him to take away his observations, to not tell what he wrote. And he actually didn't publish his work until right before his death. Yeah.
With that, did he also figure out that which planets were further away than from the sun because of like the solar orbit?
Yeah, because of the way they moved. Yeah, I think so. That's a good question. I'm not exactly sure what his other work was.
How long does it take for like Pluto or some of the furthest planets to orbit?
Oh, hundreds of years. Hundreds of years to go around the sun. And Jupiter, which is pretty far out, takes like 13 years, something like that, to go around once. And Saturn is a lot more than that, like 40 or so. I can't remember the exact numbers, but it's a lot, yeah.
Isn't it true that science says that that Pluto isn't a planet anymore? Right,
it's a dwarf planet. We'll talk about that. Because Pluto is just one of millions of bodies out there about where Pluto is. And Pluto's just the biggest, so we saw it first. But there's probably another 300 or 400 bodies, at least as big as Pluto, out there a little bit past where Pluto is, as part of this huge belt of debris called the Kuiper Belt, or the Kuiper Belt, different ways to pronounce it. And unless we want kids to memorize 400 different planets, we had to get rid of Pluto as one of the planets and call it a dwarf planet. And then kids could just memorize the 8 planets, and then everything out there near Pluto would call a dwarf planet. Does that make sense?
Uh-huh.
They've already discovered one that's bigger than Pluto.
We haven't gone to Pluto, but we've sent a...
We just drove a spacecraft by it.
Oh, really?
New Horizons last year. It passed it. Took a bunch of pictures. We got pictures of Pluto now.
With people?
No.
That's what I was saying.
No people.
Taking people.
No people.
How long did it take?
People have never been past the moon.
That's what I thought.
How long does it take to get to Pluto from?
It took 9 years, I think.
Oh my God.
Yeah, 9 years. Long time. Okay, let's go back to this though, since I'm running out of time. We'll get to all those planets and the exploration of all of them. That's cool stuff. It's very exciting stuff. This guy, Aristarchus, was the first guy to actually come up with that the planets went around the sun. He actually thought of that in ancient Greek times. But he wasn't as smart as Aristotle, or he wasn't as famous as Aristotle, and so not many people listened to his work. Aristotle said the earth is at the center. So Aristarchus is actually the first one to come up with the planets going around the sun, and then Copernicus read Aristarchus's work and did mathematics to show that that's actually what happened. And like I say, Copernicus was scared of the church, and Copernicus didn't really publish his data until near his death. And then people looked at his data and said, yeah, you know, Copernicus is right. Here's the Earth going around the sun. Here's Mars going around the sun. And you can see what it looks like according to the background stars by the way they've drawn these lines. It looks like Mars goes forward and then backwards and then forward again, depending on where it is in the orbit. And that just happens over and over. Every time Earth passes Mars, it looks like it does a little backward loop. And that's easier explanation than all these epicycles. And that turned out to be the one that was right. It took them several hundred years to drop the epicycle idea. Several people got jailed, and some burned at the stake for saying, yes, Copernicus is right. And that's just the way things were. It's a tough time back then. Nowadays there's a lot more. We got freedom of speech, and you can write up and have evidence. And but back then the church had a lot of power, and some people paid for it. But Copernicus was right, and so he's kind of famous for that. Make sense? Okay, so hopefully that catches us up. You can turn